So my talk is called Poke Your Own Mongo, Augmented Reality with SpriteKit. I'm Sarah Olson. I'm an iOS developer at Trello. I'm Director of Women Who Code in the Twin Cities, and you can find me on Twitter at Sarah E. Olson. The code for today is up on GitHub under Sarah E. Olson repos 360i dev min -poke Mongo, not Pokemon Go, Poke Mongo. So I want to talk a little bit about why I'm doing this presentation. I am not a game developer at all. I came into iOS development about 4 years ago. Before that I was doing mostly back-end, some database kind of stuff for 15 years. So I went to the nerdery as a consultant doing custom software, moved into iOS. I've done a lot of different kinds of apps. We did social media apps, flagship store apps, loyalty apps. We did a point of sale that was like a cash register kind of app, so all kinds of stuff, but we really didn't do any gaming. I've kind of done gaming as like a pastime, but I would never call myself a gamer, and I think that's pretty typical for women. Women kind of hesitate to take on the gamer label. But I think it's a really interesting gateway into mobile, and I've noticed that there's not that many women who are really doing mobile. So it's something that I've been trying to encourage through Women Who Code. So we did a hack night recently where we made a Flappy Bird clone. It's a really simple app you can build really quickly and get a little confidence and kind of build some excitement. So we had people bring their kids in, and the kids helped us come up with ideas for our app. So instead of a Flappy Bird, maybe it'd be a bouncing hippopotamus or something like that. So they helped us make the games. They got excited about tech. Their moms or parents got more excited about tech too. So I thought that was really interesting, and it kind of wanted me to explore that a little bit more and learn more about this stuff so I could help teach others as well. We also did a really cool meetup recently around virtual reality. So I had PlayStation 4 come in and bring in their new PS4 VR headset. We had Oculus Rift there, we had Samsung Gear VR, we had a bunch of Google Cardboard apps, Project Tango, Augmented Reality tablet. So we had a whole bunch of different tech, and women came in and tried it all out and hopingly build some excitement towards AR and VR technologies. And it was really well attended, so I think it was a success, and I want to keep kind of going towards that route. So today's app is me learning how to make a game. It's something new to me, so don't expect me to come in and show you amazing kinds of SpriteKit things. If you already know this technology, I probably don't know as much as you. But one of the best ways I found to learn something is to teach it, so here I am teaching it. Just in case you don't know, I'm going to talk a little bit about what augmented reality and what virtual reality are. So augmented reality is still showing your app in the real world situation. So you're taking something, you're enhancing it a little bit. Maybe you're displaying some extra graphics or extra sounds or something that just kind of takes reality and makes it a little bit different. Virtual reality is submersing yourself in an alternate world. So usually have a headset on where you can't see anything in the real world. You've got your headphones on, everything kind of makes you believe you're somewhere else in a different reality. So I was looking for some interesting charts on describing the differences, and I found this one, and I don't know that it makes any sense, but I really thought it was funny. So, so your app, I guess, is the fishbowl, and you're looking in the fishbowl, and you can see the fish. So you're really distanced from whatever it is you're looking at. And virtual reality is like you're in the ocean and you're swimming with a shark. And I was like, yeah, that makes sense. Augmented reality is inside the shark. I'm not sure why. But we're going inside the shark today. So there's a lot of new devices coming out. It's kind of one of the new hot things. So right now, HOLOLENS is Microsoft's device that they're coming out with. It's on the augmented reality scale, so that's on the left side. On the right side is the more virtual reality stuff, where you've got Gear and Vive and Oculus and PlayStation VR. But there are a lot of other devices out there. The Google Cardboard and Tango are on the augmented reality side, or Cardboard's probably more virtual reality. So if you haven't seen the HOLOLENS video that Microsoft came out with recently, it's pretty cool. It kind of shows this guy on stage, and he's got the headset on, and you can see like the monsters coming out of the walls, and he shoots them and battles them. This is kind of on the more augmented reality side. It's definitely on the like extensive side. There's a lot of things going on, things interacting, having to know where they are in space. Another example of an augmented reality app is WAYFAIR's furniture app. So they're a furniture store, and this is on the Project Tango device. You can actually like try out furniture in your house. So you pick out which thing you want, you place it in the room, and then through the tablet you can look at it and kind of see how big it is, see how it matches your other furniture, is the right height, will it fit under the table. You can get closer to it to see more detail, or further back to see how it fits in the space. So it's pretty cool, not as extensive as HOLOLENS. And then there's Pokemon Go. This is kind of augmented reality. It's not super extensive. It's on the very like low AR side of the scale. But if you haven't played it, you find little Pokemon and you like throw this ball at it and you try to catch it, and then you can turn on the AR mode and actually see it like in your living room or wherever you are in space. So we're going to build our own AR app, and we're going to use Pokemon Go as our example because we don't have a lot of time in a talk like this, and there are some frameworks out there for doing AR and VR, but there's kind of a lot of ramp up. So I thought this was like a really safe, easy space for people to start. So we're going to use SpriteKit to create a 2D game. There's also SCENEKit available if you want to do a 3D game. We're going to use the camera to augment our reality. And we're not going to do any of the other features of Pokemon Go with location or GPS or anything like that. We're starting very simple here. So this is what our game is going to look like. We're going to have a little monster that comes up on the screen, and we can turn on AR mode to see our monster in our space. And then we can throw a ball and try and explode our monster. So the first thing we need to do is actually create a new game in Xcode, and you just do that with your file new project, and you'd select the game one. It's got like a little dude doing something, I don't know. And when you open up your project, it's going to look pretty similar to what a normal project looks like. There's a couple of big differences. So when you open up your storyboard, you're going to see that you have a view controller. It's set up for you, and the only difference with this is that your view is actually an SK view instead of a UI view. And when you look into your view controller, you're going to see that it's actually using that SK view in loading a scene. And the scene is kind of the container for your game. It's where all the game stuff is going to happen. So your view controller is going to associate with a game scene, and that's what we're loading in there. And then this is like all the default stuff that comes in. It loads the scene for you and connects all that up. So if you look inside the game scene, this is where your gaming logic is going to happen. And if they throw a whole bunch of boilerplate and like example code in there, we're not going to use any of it, but it's important to kind of like look through it and see what they're doing. They kind of show you some examples. And at the very bottom, you'll see it has these methods for dealing with touch. So when a user touches the screen, what happens? We're going to be using some of those functions later, but it's just important to note, like, these are the functions that are available to you when you create a new game. So when you run the default template that you get, this is basically what it does. So it's showing you like, hey, you can put a label on the screen, and you can move your finger around on the screen, and things happen. For our game, we are going to have our scene, the game scene, and from there we're going to create two what are called SKSPRITENODEs. Most of the things that you put on the screen in a game are these SKSPRITENODEs. So we'll have a monster node and we'll have a ball node. And all of these, the SKSPRITENODE and SKSCENE, all derived from SKNode. So a lot of them have the same kind of functions available through that. So we're going to start with creating our monster, and we do that by initializing an SKSPRITENODE. and we're passing in the image of our monster. And this is something that I already set up in our image asset, so we just look for the image name Purple Monster 1 and assign our node to that. Then we need to tell it where that node should be placed on the screen, so we're setting the position. And we're setting the Z position, which is how, like, where it is in the 3D space, how deep it is. So we're putting it above everything else, so it's above our background. And then we're adding this node to our scene through the add child method. So one thing to note about positioning is that you know, typically in iOS, you kind of have 0, 0 in one space, or XY coordinates happen at the same time, but you can actually change this within your game. So I have our position 0 set, it's actually an X, but since it's at the very bottom line, it just looks like a line going vertically. But that's where our 0, 0 is. So on the X-axis, anything that's a positive number is going to be on the right half of the screen, and negative numbers are on the left half. And then vertically, everything is positive. So the middle of the screen is 0, 0 at the very bottom. So just when you see positioning code, it's all based on that. So we have a monster, it's on the screen, but it's not doing anything. So we want to start moving our monster. We're going to move the monster back and forth across the screen, and we want that to keep happening as long as we're playing the game. So we start off using SKAction is a class that you have to use that will move things, it will group things, it will repeat things in a loop. There's all kinds of actions that you can use on there. So we're going to use the move action to move it to the very right-hand side of the screen, and we're going to keep it at the same vertical plane, so it's not going to move up and down. It's going to go back and forth. So we're going to move it right, and then we're going to move it left. And if we did that, it would just happen once. So the guy would go to the right and then the left and be done. But if we group these things together in a sequence where it goes right and left, and then we repeat those things, then it will keep going. So the SKAction sequence will group a list of actions together. And then the SKAction repeat forever method will loop those actions. So we create the right, left, we group them in a sequence, we repeat that sequence, and then we call run on our node, which will run the node, those actions on that node. So repeatedly, the monster will move back and forth. And we can actually see him move now. So he looks pretty good, but he's not actually, like, his body is moving, but he's moving in space, but his body isn't moving. So what if we have him move his arms and legs while he goes back and forth? In order to do that, we need to actually create a texture atlas, and that's basically going to group a bunch of images together so we can make an animation from it. So we'll create our texture atlas, we'll assign it an array of images, and then we use the SKAction to animate method to pass in those images, and then we have to tell it how quickly we want those images to change. And that's something you can play around with to find the right setting that works for you. I have it set at 0.2 seconds. And then we're going to repeat that animation forever, because otherwise it would only happen once. And then we'll call the run method on our monster to actually kick that off. So now our monster's arms and legs are moving. So we have a monster, but we don't really have a game because he's just moving around. So we want to make a ball that we can throw at him. And we do that in much the same way that we did with the monster. We're going to create a new sprite node. We're going to pass in the ball image to create that node. We're going to set its position, so we want it to be at the very bottom in the middle, but 100 points up from the bottom. We're going to also set its Z position to 2, so it's on the same plane as our monster. And then we're going to scale it because my image was a little too big, so we're going to make it a little bit smaller. And then we're going to add that node to our scene. This one doesn't move. So we can just see that there is a ball there now, and it doesn't move. So how do we move our ball? And here's where we're going to use those methods that you saw when we created our default project. We actually need to move the ball based on where the user is touching the screen. So in order to do this, we need to use the touches began, touches moved, and touches ended methods. And these methods will be called for us when the user actually presses on the screen. So when touches began, we're going to record where that initial touch location was, so we can reference that later. When the touch is moved, so the user has their finger down on the screen and is dragging it, we're going to move the ball along with that position. So we record where that position is, and then we set the ball's position to that same position. And then when touch is ended, we want to record where the end was. And we're going to use both the start touch location and the end touch location to know where our ball has moved to, so we can calculate our trajectory for which direction it should go later. So you see right now, our ball will actually move with the finger, but it doesn't keep going. So in order for our ball to continue moving through a somewhat realistic environment, we need to use physics. So physics is something that is provided by the game framework, and each node can have a physics body. So our physics body will determine how it reacts to other objects, if it reacts to gravity and other things that kind of simulate real-world environments. And when you create a physics body, you have to tell it which kind of body you want. So there's a rectangular body, there's a circular body, or there's one that kind of wraps around an image and kind of ignores any transparent space, so it hugs an object more tightly. And this is just so when you have objects collide, it knows where that object really starts. Because we have a ball, it's already a circle, so the circle type fits it already. So we're going to use that. And we're setting is dynamic to true, which means that the object can move around. If we have it false, it's static. We don't want it affected by gravity, and the reason for that is if we started our game and we had our ball kind of up in the middle of the screen, it would just fall right to the bottom, and we don't want it there. We want it to start kind of above the bottom and then only moves when the user gestures. It doesn't need to rotate, so we don't have to worry about that. And mass is a setting you can use to determine like how heavy the ball is, how much it is affected by gravity, how quickly it drops. So you can play around with that. So inside the touch is ended, which is when the user releases their finger, we want to actually throw the ball into our environment. So there's a couple ways to do that. One is on a physics body, they have a method called imply impulse, and that's going to kind of initiate a thrust and then stop. So you're going to have one push of the ball, and that's what we want here. So we're going to use that. And the way that we're calculating where to send it is to look at our start position and our end position and kind of find that angle, and then we're going to continue on in that same direction. So when the user releases, the ball continues to go in that same kind of path it was going before. So we're just looking at the difference between the end touch and the start touch. So when we add in that code, we can actually see our ball continue to move after we release our finger. So that's great, but after we throw the ball, we don't have another ball to throw, so we're kind of stuck. So we need to reset the ball when it leaves the bounds of our scene. So within the update method, this is a method that's going to be called each time the frame is rendered. And if you're typically seeing about 60 frames per second, this is going to be called a lot, 60 times each second. So just note when you're putting stuff in here how often things are changing. It might determine what kinds of things you should put in here, but checking positions of things and changing things based on that is a good thing to put in here. So we're looking at where the ball is inside our scene, and once it goes past that scene, we want to do something. So right now we're looking, is it gone off the right side, off the left side, or up vertically off the screen? And if so, we're going to reset our ball. So to reset it, we're going to remove all the actions that are currently running on it. We're going to remove it from the scene, that's removed from parent, and then we're going to set our variable that keeps track of the ball to 0. We're also going to reset all the touch locations because we're starting over, there's no more ball. And then we're going to create a new ball, which is using the same method that we did to initially create it. So now we can throw the ball, it goes off the screen, and a new ball appears at the bottom. So we have a ball, we can throw it, we have a monster, but it doesn't actually do anything when our ball hits our monster. So how do we know when that happens? Inside that update method, we can create a function to check for collisions. So inside check collisions, we make sure we still have a ball and a monster on the screen, and if so, we're going to look to see if the ball's frame intersects with the monster's frame. And we're going to inset it just to make sure that we get a little bit inside it so it's not, it looks a little jarring otherwise if you kind of hit the outer edge of the boundary. So the ball will have to intersect the monster a little bit for this to get called. And then when that happens, we call monster hit, which basically does the same thing as we did with the ball. It removes all the actions, it removes it from the scene, and then we set our local variable to no. So now we can actually throw, and our monster disappears when it gets hit. But that's not super fun. And then we don't have another monster available to hit again, so now we're stuck, and we need to reset our monster. The problem with just creating a new monster at that point is that you don't actually see the monster disappear because it gets recreated right away. So one way to deal with this is to use the SKActions wait method and pass in a second. So we're going to wait 1 second after the monster gets hit before we create a new one. And then you can just pass in the method you want to call into the wait action as a completion block on the run method. So now when we do that, we hit our monster, and then a second later, a new one appears. So to make this a little bit more exciting, we're going to have our monster explode. And we're going to do that through the use of a particle. So if you go into the File, New File menu, you'll see a SpriteKit particle file. And if you create that, you see the list of particle options that are available to you. I haven't found a good way to browse these to see what they look like besides actually creating them and messing around with them. So maybe just have a little fun and create all kinds of particles and see what they can do. And then when you get into your particle file, this actually animates so you can see the explosions. There. And then you can mess with all the settings on the right-hand side. There's all kinds of stuff you can do with these, and you just kind of play around until you get something you like. So the two things I changed were the emitter maximum to make there less particles flying about, and the position range. So that kind of gave me the feeling that I liked. And then here's the code to actually add your particle into your scene. So this would happen inside your monster hit method. After your monster disappears, you would call the SKEmitter init method with passing in your spark particle that you just created. You'll set the spark position to the same position as the monster was, and then I set the color to purple because our monster is purple, and you add that node to your scene. There we go. So now he explodes. So we've got our basic gameplay in there. We have a ball, we have a monster, we can throw, the monster explodes. So now it's time to add in our augmented reality. And really this is the same code that you would use when you're creating a barcode scanner, which I've done many, many times. But you're basically just going to display a live camera feed behind whatever objects you have on the screen. At least that's the way I went about it. So you need to make a few layout updates to accommodate this. I added in just a basic UI view that was clear and set that up as a camera view. So it would be a separate view than the background. And then I also created a button so I could toggle between the two. Now when you're using the camera, you have to ask the user for permissions. So this is the code I put in for that. Basically, if the user hasn't authorized it, we prompt them to do so. If they're already authorized, we can just display the camera right away. Otherwise, if it's denied, then they just can't do it. And don't forget, when you're adding in this, you now need to add in an NS camera usage description that will be displayed to the user when they're prompted for access, that explains why you want access to their camera. So configuring camera capture. This is where we're actually setting up the live camera feed, and this is kind of the similar code for the barcode scanner. You have to import AV Foundation, and then I have a variable just to set when we have configured it, so we don't have to configure it more than once. And then we're using AV Capture Device to tell the system that we want to capture video, and we're specifying that as our type of device input. If anything goes wrong, we're printing out an error. And then we're just setting the layer of our camera feed to that camera view that I created earlier. And then at the very end, we're setting our flag to say that we have configured the camera. And then to actually display the feed, we need to first make sure that they're authorized to do so. If the camera hasn't been configured, make sure you do that first. Otherwise, start running the AV capture session, which will display the camera feed. And then to toggle between the two views, we just have a setting to show whether or not we're in that AR mode. And then the button action is with this tapped AR mode button function. It's going to change the toggle, so we're now in AR mode or not. If we are in AR mode, we check for camera permissions, and then we change the title to be the opposite. If we are coming out of AR mode, then we need to change the title back to AR mode, and we need to stop running the camera feed session. And then we're basically showing or hiding the background view, which has the image behind it, or the camera view, which is playing the live camera feed. So here's our app. We can actually toggle between the two views. That's my desk. And then we can hit our monster and he explodes. So we created an animated moving monster. We created a ball that we can throw. Our monster explodes when we hit it. And we're displaying a camera view to show our augmented reality. Very, very basic version, but sort of augmented anyway. So the game code's up on GitHub. I have my slides up on SpeakerDeck. Again, Twitter, Sarah E. Olson. And if you have any questions, let me know.